we continue to the lecture, it will be as follows. So, um, as for example, for the stars being born in a universe, we can take Orion Nebula. Obviously, the star content of our galaxy has changed over time. To understand the formation and evolution of the galaxies, and so um, for instance, in the well-known Orion Nebula, and obviously the cell content of our galaxy has changed over time, as I've said. And to understand the formation and evolution of the galaxy, a view of its past would be useful. So to understand galaxy, starting with the galaxy, or say how the formation of the galaxy started, we have to say in detail the past history of the galaxy. The past history of the galaxy can tell us when the galaxy was born. So, unfortunately, this is physically impossible. And however, due to the finite speed of light, we see objects at larger size in an irreal state as they were. So now the speed of light can help us judge the age of the galaxies. So, due to the finite speed of light, the speed of light is, as we know, finite. It is 3 times 10 raised to 8 meters per second square. So, because of the speed of light, or the finiteness of the speed of light, we see objects as large as in an earlier state as they were in the past. So, because of this speed of light, as they were in the past. So, objects in the objects in the at large distances from us, the objectives at large distances from us are seen as they were in the past because of the speed of light. Because of the speed of light, so the more distance or the large distance from us, it can tell us that that object is that object is in the past, or that object is being born, or that object is starting to be in the anticipation, or in the construction. So that's what we can understand according to astrophysics or physics or astronomy. And so speed of light can help us here to know the objects in the large distances. The objects in the large distance when it is seen at the speed of light only. If it is less than or greater than the speed of light, we cannot make this prediction. So the objects in the past can be known by the large distances in the universe. One can now try to identify the analyze such distance galaxies, which may have been the progenitors of galaxies like our own galaxies. In this way, reconstructing the main aspects of the history of the Milky Way, we will never know the exact initial conditions that lead to the evolution of the Milky Way. But we may be able to find some characteristics, conditions emerging from such initial states. Cosmic evolution should produce galaxies similar to our own, which we would then be able to observe from our own galaxy. We can study physics of galaxy evolution in situ. These technical advances has led to the vast increase in knowledge and insight in astronomy, especially in extragalactic astronomy and cosmology. Large telescopes and sensitive instruments have opened up a window to the distant universe. So, in order to make a research on objects at the large distances, scientists are using the telescopes and sensitive instruments like lasers, especially to measure the distances between the different objects in a universe. Lasers are being used as well as the telescopes are also being used like Hubble telescope, which were sent in order to investigate the galaxies. And also, since any of the observation of recent objects is inevitable, also a view into the past, due to the final speed of light, studying objects in the early universe has become possible. So as I said, because of the speed of light, because the speed of light is finite or it is constant, we can objects as large distances are the objects at the large distances are in the past, as we can predict using different calculation in physics as well as in the astronomy. Today we can study galaxies which emitted the light we observe at a time when the universe was less than 10% of its current age. These galaxies are therefore these galaxies are therefore a very early evolutionary stage. We are thus able to observe the evolution of galaxies. Throughout the past history of the universe, we have the opportunity to study the history of galaxies and the start of our own Milky Way. We can examine at which epoch most of the stars that we observe today in the local universe have formed, because the history of star formation can be traced back to early epochs. In fact, it has been found that a star formation is largely hidden from our eyes and only observable with space-based telescopes operating in the far infrared wave band. Most of the galaxies are not visible to us; they are hidden um, from our natural eye. So, but they can be observed by the telescopes, which can function, or which can of the infrared wave band. So one of the most fascinating discoveries of recent years is that most galaxies harbor a black hole in the center, which characterizes mass of millions or even billions of solar masses, so-called supermassive black holes. They are also, so when we say black holes are um, the characteristics of black holes are known that when the objects approach them, that object will expand and expand and expand, and after that it will be changed to something invisible, or it can downgrade as the physicist um, Hawking predicted, or as he put in his state of black hole, in the state of black hole. And even more surprising was to find the black hole mass is closely related to the other properties of its parent galaxy, as is predicted, or as the science discovered. In our galaxy, there are different black holes. There are different black holes, thus providing clear indicating the evolution of supermassive black holes closely linked to this, which are called galaxy groups or clusters of galaxies, led to surprising result that these objects contain considerably more mass than is of stars gas. And as of the dynamics of galaxies and clusters show that only 10 to 20% of their mass consists of stars gas, and thus that we are able to observe in emission or absorption, in emission or observation. The largest fraction of this their mass, however, is invisible. Hence, this hidden mass is called dark matter. So, as we saw, this hidden mass is called the dark matter. The dark matter is um, as I've told you, there are different analyses made on the dark matter. Less of the dynamics of galaxy clusters show that only 10 to 20% of their mass consists of stars. And So the 10 to 20% of the galaxies contain or consists of stars, gas, and dust that we are able to observe in emission or observation. So we can see, or we can know, or we can judge or understand that there is 10 to 20% of the galaxy is stars, gas, and dust. So we can observe them by knowing the emission and observation. Like the emission can be through the different gases or dust or something, and the observation also can be through different mechanisms that scientists use, and they can predict the observation and the emission observed in our galaxies. The largest fraction of their mass, however, is invisible. And also the mass of the galaxies. Most of the mass of the galaxies cannot be determined, as well as is invisible. This invisible mass or the hidden mass is called the dark matter. That's this is called dark matter. Thank you very much. That's what I prepared for today, or for the second lecture. Thank you. We'll join you again next time. See you.